Alright, let's have us a map of what we have learned. And I know that you have seen the map before, but we are going to add a few extra things to it. We start with our very first question, as always. What is it you'll be testing? It either is going to be a mean or a proportion. And before we cleared this whole side of the map out, but now we've got some proportions that we can talk about. For each of these, we ask the question, how many of each of these are we testing? We could be testing one mean or two means, and same for proportions, one or two. There's also an option that we have not yet talked about testing many means, specifically going in a straight line, or many proportions, which we will get to later. But for right now, we have one or two of both means and proportions. Now, in every case, there is this wall. And so far, this wall is entirely made of the question, could the data be normal? That is the assumptions that we are working with. For some of these other things, there will be other assumptions that we will need to worry about. But how do we know if we have one mean whether we can get through the assumptions? The assumptions that we need are that you know the normality, or you know that n is greater than 30. One or the other path can get you through this wall. If you have two means, then normality or both the ends must be greater than 30. For proportions, there is no magic, it is normal. You cannot have normally distributed proportions. They are yeses and nos. But you can have 15 yeses and 15 nos. For two proportions, I realize that text is too small to see, but you know the rule. NP greater than 15 for both groups, and 1 minus p greater than both groups. If you do not have that, you are petach, and you must stop the test immediately. Now, if you do know that it is normal, then you go to the next question, which is, do you know sigma? If you do know sigma, this is the z-test that we are used to. And you do z equals x bar minus mu, sigma, because you have the sigma right here over square root of n. For the confidence interval, you are going to take this equation and you are going to write it in a different way so that it is x bar plus or minus z sigma over the square root of n. On the other hand, if you did not know a magic sigma, then you must use the s, which gives you almost the exact same thing, except where we had z becomes t, and where we had sigma becomes s. This equation also can be written with a confidence interval. Now, going back to the scenario where we have two means, the question you will want to ask yourself is not whether you know sigma or s, because we are never going to have sigma for this scenario. Instead, we will ask ourselves, is it matched pairs? If it is matched pairs, watch, I will cheat because I am running low on space for this board. The answer, yes to matched pairs, goes back to this test. Keep in mind, the x bar will be of the differences, as well as the s of the differences, and the mu specifically will be a 0. But using this little trick, I can save myself room on the board. If it is not matched pairs, then you'll be using these two sample independent t-tests. And for the t-test, you have two different x bars here, and 0, of course, because you are comparing two things against each other. Down here, you have this for your standard errors. That should make sense. If it does not, you need to talk to me so that we can make sure you understand why that right there works. Confidence interval is the same idea as before. We take this equation and we rewrite it. And now we move over to the other scenario where we have proportions. And for proportions, if we have one proportion and you know that the sample size is big enough, then you do not need to ask any more questions. You already know it is a one sample proportions test. And we use p hat instead of x bar, and p and the square root of p1 minus p, but this works very similar to this one. I hope that you can see the pattern. To get our confidence interval, we rewrite this one. Notice that the p hat changed. It used to be p, and now it is p hat. For a two sample proportions test, once we know that the assumptions are met, we don't need to ask any more questions as well. It's just straight to the two sample proportions test. we're going to do the two different proportions, just like we did two different X bars over here. And this idea is the same as this idea here. The standard error for one and the standard error for the other. Now it depends on that P bar. And so to get that P bar, what you're going to want to do, I'm going to have to write it up here because I'm running out of room on the board and I got to stick this somewhere. It's going to be the number of people who said yes in group 1 and the number of people who said yes in group 2. And we are going to divide that by getting high over markers. You guys have no idea because I am right next to the board. Woo! Really? Okay, who's offended? The Trekkies are offended by the Klingon accent. Well, at any rate, here is our map of all the different things we have learned. You can follow this to try to figure out what hypothesis test and which equation you need to use. And I officially apologize to all races, people, nations, and fictional characters that I have imitated.